you probably heard from Yusuf, and it's in everybody's mind within the biopolyols business, that our vision is to be the global leader and the partner of choice in performance-based biopolyols. That's what we want to achieve. And we embarked on a journey. And that's how we see this development and the development of such capabilities. As you know, this was a very fast-paced project. It went from idea to commercialization and of the first generation product in less than 3 years, so which is a fairly fast time frame. The polyols that we have in the marketplace today, they constitute the versatile chemistry, and we say that they present endless possibilities in this space. They feature low odor, they are quality consistent, which are two of the characteristics that in the past would prevent the utilization of such polyols in the flexible foam industry. It is well known that castor oil was used widely in the manufacture of flexible foams. However, with a few shortfalls, one of them being quality consistency. And other bio-based polyols had the issue of odor. So nobody would like to sleep on a mattress that smells like French fries. So this was an issue that we had to come up with. And already with our first generation products, we bring higher levels of polyether polyol replacement, as I will indicate throughout this presentation. These polyols were also designed to work with commercially available additives, which makes the life of the foamer much easier. There is no need for any special additives or any very sophisticated kinds of additives to use these materials. This is a chemistry that is also detached from propylene and propylene oxide, or ethylene and ethylene oxide. Our polyols have zero content of propylene oxide. So we have an innovative chemistry that allows us to grow molecular weight and functionality without the use of such chemistries. And last but not least, these polyols have very large or very high renewable content, higher than 95%, which is unique in this space today. Finally, this we see it as technology in evolution. It is the first step in a developmental journey. Yes, these products yet do not replace 100% of polyether polyols, but our development objective is to continue in this developmental journey to get to 100% of incorporation levels. So every journey must start with a single step, and this was the first step that we took. Now, I want to walk you through a little bit about how we started and where we were and where we are today. The very first products that were brought into the marketplace were Bio 5000 and Bio 2100. And their initial applications were in conventional slab stock and in TDI molded. And as you can see, we started with levels of replacement of up to 20 parts in conventional slab and about 5 parts in TDI molded, primarily to build load. Now, over the course of this last 2.5 years, not only we have made significant improvements over the technology and how it can be used, but also customers became more familiar about how to process these polyols. And the result of that is that not only we went from conventional slab stock to other applications such as high resilience, viscoelastic foam and carpet backing, but also the amount of utilization increased because customers now understand how to handle these products, how to formulate, and how to optimize the utilization of these polyols. So we were able to significantly increase the levels of utilization for those two polyols, including, as you can see now, Bio 2100 being used in MDI molded and also in flame lamination applications, which goes into primarily automotive applications. Now, evidently we don't stand still, and the reason why we have this laboratory is to create new products and new technologies, and that's what we are working on. We came up with a new product for molded foam applications, which we internally call it X0001, which is a clear molded polyol, which is being proved to be very effective in both TDI and MDI molded at fairly high levels of utilization, basically doubling what we had before. Next week at the CPI, we are going to be featuring X0002, which is a solids-free option for load building in foams. And it is a one-to-one replacement for styrene acrylonitrile copolymer polyols. As a matter of fact, we are just this week finalizing field trials at customers where this material successfully replaced 100% of the copolymer polyol out there, both in HR foams as well as in conventional foams. This represents a significant advance for these types of polyols in the industry, primarily in the US, where the conventional slab stock foams utilizes CO2 as blowing agent for low density foams. And this being a solids-free material, that makes the lives of the foamers a whole lot easier in terms of handling and in terms of processing. Next, we have 0005, which is a polyol specifically designed for viscoelastic foam applications, both in slab and molded. And here I want to call your attention to the fact that we are going all the way up to 75 parts. So we are making significant strides to get to our objective of 100% replacement of polyether polyols. And again, because of the investment that we're making, we don't want to be restricted only to flexible foams. We're also going into rigid foam applications. And for that we have X110 polyol, which is now being used in PIR, spray foams, and pour in place. And in certain pour in place applications, it can be used up to 100 parts. Not all of them yet, but in certain, which I'm not at the liberty to say which ones are the ones that it can be used at 100 parts, but they can be used at 100 parts. So again, the fact that we have now an R&D center where synthesis, analytical work, and application development work can be done under a single roof significantly increased the speed with which we can bring products and services to the marketplace. Now, we cannot make a presentation about a bio-based material without talking about its impact in the environment. And the processes utilized to make Cargill biopolyols bring significant savings in terms of energy and reduction in global warming potential emissions. From an energy standpoint, our process presents a reduction of about 23% reduction in total energy demand and 61% reduction in non-renewable energy use. And in terms of global warming emissions, we reduce up to 36% such emissions. So bringing a smaller environmental footprint altogether.